Welcome back to Tech, Tesla, and Trends. Tonight we're going to revisit zero-emission cargo ships. As discussed last night, if Tesla entered the cargo market, what would they need? Potentially, it seems a zero-emission ship might be a goal or an aspirational for them, as diesel ships are one of the large carbon sources that have been identified as needing to be replaced in order to get to that sustainable energy future. So I thought I would look at this from a design perspective as well as what's been done with electric cars, as electric ships are essentially transport on sea where electric cars are transport on land. And in looking at that, there are some obvious differences. You have buoyancy and the overall weather that is part of that process. So you can't have giant windmills strapped to the top of ships. I know I've seen some pictures of those, or some vertical windmills that are out there. I know that they've been testing some of those as alternative power sources for ships, and the progress is occurring. There's still room for a lot of innovation in this industry. I know that there is a full battery only ship, zero emission, the Yara Birkeland out of Norway. And that particular one is for shipping fertilizer and eliminating truck traffic in Norway from between where it's brought to and where it's processed. So that particular vessel is only capable of 30 nautical miles. It's a full battery and supposed to be an autonomous ship too, which is a great idea. But ultimately, the challenge that Tesla would face in the near term, if they were designing ships, is how much efficiency could they eke out or to change to improve the overall designs that exist today. I wouldn't expect that they would have any massive changes or ability to implement something of earth or of sea shattering perspectives in less than, say, 5 to 7 years once they enter that market. So the challenge there becomes what technologies are available in that arena. I see solar, wind. There's potential for wave action and that could operate from an additional charge to the battery, that potentially extending the range. Those particular options, though, are not currently capable of taking a cargo ship across the Pacific or the Atlantic. And that is the true challenge. So in looking at that, I thought, what would be necessary? Well, I know that there are small buoy-like tender ships for wind farms out in the sea and off the coast of Norway as well. There's a lot of innovation coming out of Norway these days, as they have fully committed to meeting their sustainable goals. And as they move forward with that, they are creating a sort of a buoy system that would provide power to the tender ships that are out there repairing or maintaining the wind farm out at sea. Those are typically diesel-powered ships at present. and in order to have power at sea, they have to have diesel engines running. So having a buoy that they can moor to, it's an efficiency there. It makes a lot of sense, and it's an alternative that exists. But another concept that comes to my mind is, how could you take that same moored buoy and transition it into a staged power station where you could charge a ship out in the middle of the Atlantic or the Pacific? And I know that the University of Hawaii has had some, it was a competition for autonomous underwater vehicles, and I'm drawing a blank as to what the competition was at the moment, but I remember seeing that particular competition while I was surfing during COVID. Anyways, it's an option out there, and again, I think in that case they were, if memory serves, that was like a wave chamber, so they were using air to push turbine in and out and to generate power that way for those autonomous underwater vehicles that I think it's the Navy or NOAA are probably monitoring wave action or something like that. Anyways, neither here nor there on that, because if you take an idea like that and upscale it, and then perhaps add some sort of tendrils that would hang down that you could utilize for some thermal action there, and try to increase the overall potential there to generate energy at a large battery floating station. And then you would have, you could also have a little bit of wind on that, and probably solar on the exposed surfaces, and overall you have a giant floating charging station. And those could be easily GPSed and known where they're at, and have their own little station keeping, or even potentially anchored in places that would provide those mid-ocean charging stations, if you will. As the overall technologies improve, those charging stations could move as range increases, or be like, obviously the fleet's not going to all upgrade all at once, so there's going to be a need for those ships as they exist, and those charging stations once those ships exist. The Yara Birkeland tells us that cost curves can come into play, and that's an important thing to remember. As Tony Seba has taught us, cost curves are like gravity. They occur. And because that happens, the cost overall for these ships will come down. But more importantly, the efficiencies of the motors that drive, and the batteries, and all of the charging capabilities will continue to improve. An example that I was looking at the other day, which was a wind farm that is installed near me, that they have 11 turbines out there, and by adding 11 more turbines, they're going to be able to effectively triple the output that they currently have. So the efficiency of those turbines that are coming online are more capable, will produce more for that same amount of real estate. And that's something that a decade has gone by since those first turbines were installed. So as we look at that and realize that time is a factor here, and that's the third principle for how Elon tackles a lot of projects from from the perspective of my multidimensional solution process that he appears to follow, as far as I've been able to see. And that time occurs in that perspective of innovation as a pushing the overall development long term. Another 10 years from now, and that puts us into the 20 million per year car manufacturing phase for Tesla. And as all of those technologies have continued to develop, if Tesla were to enter this particular industry and to begin to research how to make nautical ships more efficient in the power generation and power utilization as they are currently doing with cars, there's a good potential that they would be able to not only enter that shipping industry effectively, but also innovate and potentially disrupt another industry over time, which is technically one of the things Tesla does very well. So I believe it's possible that Tesla could, if it desired, enter that electric zero-emission shipbuilding world and manufacture electric ships more efficiently than any other current shipbuilding yards. Obviously, as we've learned from electric cars, they wouldn't do it very well at first. But I would wager a bet by the time they were to the equivalent of the Model 3 or the S even, I think they would be sufficient for the needs of what Tesla has. And by the time they reach the overall design iterations where the Semi is at today, the world would be very much appreciative from that overall shipping perspective. Because with electric zero-emission ships comes autonomous ships as well. The current versions that are out there are the equivalent of those HD map LiDAR bound vehicles of death once they exit their sandbox. Tesla would have the ability with FSD to port that to the ocean, and it would be very effective from a perspective of where they will be in a decade's time. So long term, I think that it's a potential that could do a lot of good for the overall world, especially as the automation of shipping becomes a larger priority and possibility. Take some time to think about it. I'd love to hear your comments and your takes, what you think I'm totally off on, and let me know what you think has potential. And any questions you've got, feel free to add those, and I'll probably make another video on this at some point in the future, and see about answering those and finding some examples that might be of value. For now, have a great night, and we'll talk to you a little bit later.